start recording today's session now. So, when we began, we first of all we have looked at data science, looking into the past. But now it is also good to see data science predicting the future. So, basically, data science predicting the future is what we call predictive analytics. And these, in most cases, we call it explanatory data analysis and so on. As we said, what normal happens once the business intelligence reports and dashboards have been prepared and you extract those insights, then you use that information now as a basis for predicting the future values. And therefore, also, when you are looking at the accuracy of those predictions lies in the methods used. So basically, what is clear here is that about predictive analytics looking into the future is that it depends with the reports, the analysis, and so on that a business intelligence analyst has done. Then someone else can pick and proceed from there. So, and also what is coming out clear when we can recall the difference between traditional data and big data. Uh, Also, when we are looking at predictive analytics, we have what we call a distinction between the two, because we have what we call the traditional data science methods applied versus what we call the machine learning methods. So the traditional data science method mostly deals with the traditional data, and the other one, of course, deals with big data. So I just want us to look at the traditional methods first, and maybe as part of the recap, just we say that traditional data mostly is structured. Structured means that it is more organized, like you have a list of students and so on. That's why it is very structured. So we have what called the traditional forecasting methods. To forecast is to try to see what will happen in the future. And these methods mostly were composed of classical statistical methods, such as what called linear regression. I'm going to explain. There's a demonstration somewhere there. Clustering, factor analysis, time series, and so on. But you see, when we started, I say that in the past we have the statisticians. Those were the people who are using these traditional data science methods. Now they are being replaced by machine learning engineer and so on. So basically, when you are looking at the output of this, mostly it feeds into this machine learning analytics. And okay, as I said that these things sometimes are not very clear, because also in some industries in data science, they refer those methods as machine learning as well. But when you are looking at machine learning, we are looking at newer, smarter, and better methods that are used to do this kind of analysis and so on, especially like deep learning. Like in deep learning, for instance, let me give you an example. Like in deep learning, today I just want to give you what I apply on a day-to-day basis. Just a minute. So when you're talking about deep learning, for instance, deep learning, you are looking at how the machine learning model can learn from maybe patterns and so on. And for instance, today, when you are using a mobile application, like you come to Finberry mobile app, you want to apply for a loan, then we give you a questionnaire. As you are completing that questionnaire, we are not using the data that you are using in completing the questionnaire. Like when I ask you how, like the amount of salary that you are being paid, maybe how much income you are making in a month and so on. What I'm interested in is what called metadata. Metadata means like I'm not going to use the data that maybe Sam is giving me, but I'm trying to extract the data that is not visible, that Sam is not aware. Which kind of data is this? Like when I ask you how much you are earning, then you input 50,000, then you erase it, you input 10,000, you erase it, then you go to 10,000, you erase it. What I'm interested in is the number of time, like how many times you are trying to input data. So it means like when you input that data 3 times, it means you are not sure of how much you are earning, and maybe you are just trying to deceive me. So the model is able to learn and classify maybe this kind of customers as those who are not good customers and so on. So this model will keep on learning and so on based on some kind of training. Those are now what you call smarter methods. In fact, when we are talking, for instance, fintech, what has led to the growth of fintech is this data science and so on. In the past, we did not have fintechs. Like today, you can download a mobile app and get an secured loan without so much underwriting paper and so on. Without this industry, the data science, it won't be possible to offer such kind of loans. So I just want us to look at these traditional methods, traditional methods that were used or are used in predictive analytics. The first one, we are talking about linear regression. Mostly, these ones are used to, first of all, before even I read what's there, because not everyone is from a technical background. When we are talking about linear, we are talking of a straight line. I know you learn this practical in the statistics unit, but when you are talking about linear, there is that concept of straight line. And this one, mostly we use it in quantifying the causal relationship among different variables in the analysis. For instance, you have marketing budget, then you have the number of customers that are being closed and so on. What's the relationship that if you are going to increase the marketing budget, we are going to increase, or the number of customers are going to increase and so on. So that's a linear relationship. Like if we are going to reduce the marketing budget, does it mean the number of customers that we intend to acquire is also going to drop and so on? That's a linear relationship and so on. So, for instance, here, based on the example that is here, like we are talking about the relationship between house prices and the size of the house, the neighborhood, and so on. Like, for instance, in any capital city or wherever, we have those people who are, we have those high end areas that the prices of houses are high. We have those that are medium, and we have those that are low. So one of the factors that will determine how much, so the price of a house is one of the variables that will keep on changing. And this variable called the prices of house will keep on changing, first of all, based on the size of the house. Secondly, maybe based on the neighborhood, and also based on the year that was built, and so on. So, so you can use this now, the historical data, because we say that first of all, you must use the historical data to predict the future. So you build now what you call these models with these variables that can predict the price of a new house. For instance, um, if based on my traditional of the business intelligence analysis, I find out that for uh, for every increase in the prices maybe of the houses, there's a 1.2 or there's a 10% contribution in terms of the neighborhood and so on. So I'm going to use that 10% maybe as a factor to foresee what will happen in the future. So generally, linear relationship works like that. Like it's trying to look at two variables that are like directly proportional and so on. And I'm also sorry that I did not get the industries that you guys are working, for those who are working, uh, because I like using such individual industry case studies and so on. So, another traditional method that is used in predictive analytics, however, this one as well, I see it being used in uh, modern data science, is what we call logistic regression. So not all variables can be linear, like the relationship between those variables, as we said, like the prices of land and the price of a house and maybe the house, the place, the year built, and so on. The relationship is not always that an increase in one will lead to an automatic increase on in the other, and so on. So, in case we don't have such relationship, we have what we call logistic regression. So, this one, for instance, as you see that we can apply to filter job candidates during their screening, and if the algorithm maybe estimates that the probability that a prospective candidate will perform well in the company within a year is above 50, this is just a threshold that you set, then it will predict successful. Otherwise, unsuccessful. Let me explain in a simple language. So, first of all, this logistic regression, uh, we are using it also in these loan applications. In your email, if currently you open your email, you will find a spam folder. We use it in detecting fraud, in insurance, in finance, and across various industries. We use it to classify customers. So basically, how it works with binary. Binary data means two. Binary means two. Like for instance, male, female. Male may be represented by one, female by zero. So, for instance, let me pick one case study. If, for instance, I'm having various claims in insurance industry, and I have been able to detect some of the fraudulent claims, what I'm going to do, maybe all fraudulent claims, I'm going to code them as one. Then those that are not fraudulent, I'm going to call them as zero. Then now, I'm going to use the data that I already have. That's why I say that predictive analytics only happens if the business analytics has already occurred. So what happens that I'm able to train my data that in case almost if such kind of a claim comes, let it be flagged as fraudulent. Or in finance, for instance, on online payments, if today maybe some Sam is trying to make an online payment, and I find out that when inputting those details, Sam is inputting maybe his real name, but the card that is being used for payment does not reflect your details. That one we can classify as maybe a risky transaction. Then we flag it for manual approval. Then those that the information is consistent are being completed automatically and so on. So logistic regression is a classification like it is mostly used in fraud detection in both accounting, in various industries. The applications are immense as long as you are able to classify your data. This is like this, and this is like this. Then it can assist you to do that. You will as well do it practically. Then we have another one called clustering. So this one mostly we apply it when the observations in your data form groups according to some kind of criteria. And this cluster analysis mostly takes into account some observations that have or exhibit some similarities. And what it does is that it facilitates the discovery of new significant patterns. And we are talking about the patterns that were not part of the original data. And I just want to give an example here. For instance, when we go back to our housing data example that we have seen in linear regression, so you can have several clusters, like you can have small houses with a high price, and this one mostly can happen in city center. Then as well you can have big houses that cost less, and these ones are houses that maybe are far away from the city center. Then you can have as well big houses that cost a lot. Maybe these are houses in nice suburban neighborhoods and so on. So as you can see from these infographics, I want you to understand based on what you see, not the content that I'm trying to explain, like what is written here, because that will be coming. But just look at the infographics. If you look at these houses, the one with a golden yellow ring, they are almost of the same design. The one with I don't know if this is pink ring, they are almost of the same design. And the one with the dark blue ring are also part of the same design. And before I proceed further, given that I have explained what clustering means, and by you have seen or you have been able to see as to look on the examples, I want to pick one person. Maybe let me pick Claire. Claire, are you in the industry? Hello, Claire Buhala.
Hello, sir.
Yes, I was asking, are you in the industry? Like,
No.
okay. Let me. I just want someone in the industry. Let
Okay.
me pick Benson.
No, I'm not in the industry.
Okay, thank you. Gertrude Cherotich.
Me, I'm in telecom.
Oh, you are in the telecommunication industry.
Yes.
Okay, thank you. Yeah, there was a student, another student. I think it was May 2020. What intake 2022? I don't know if she's still there, but It is nice to hear that you are also from there. So, where do you think your organization can apply this clustering? If you have understood it well.
Let me not guess for now.
Okay, thank you. Anyone in the industry who has understood this and maybe you are seeing that you are having an issue in your organization that can be solved using this clustering. Yes, Venetia.
Okay, good evening.
Good evening.
So, I'm also in the telecommunication industry, but on the fiber side, fiber to the home. So, I think on our side, we can use clustering when we are doing rollouts for the new area for fiber, and it will help us to predict on how, because when you come to fiber to the home, there are those that use fiber to the business and then fiber to the home. So clustering can help us in that.
Okay, thank you so much, Venetia. For basically, my objective was what I wanted is to see if guys have understood this concept of clustering. That was my objective. But you will do it practically. So there's another one called factor. We have clustering. Clustering mostly we are looking at, you are trying to group observations together. But now factor analysis, what it does is grouping features together. Like I don't again want to read everything here, but let me to explain what factor analysis like. You are having a lot of variables, like in your business, in marketing. You are not very sure. You are not very sure, like maybe the factors that influence maybe your customer purchasing power. But you have a very big list, of what you think of. So what factor analysis does, it assists you to reduce that list of those features, and it reduces them and assists you maybe to remain with only two important. Like you are having a list of variables that you are looking into, maybe that affects a certain process, and you are not sure which one should I pick, and so on. Factor analysis just assists you to reduce them to a more reasonable level that you can apply and be used in decision making. Then the last one, on the traditional one, is what called time series. So time series, when you are talking about time series, always, as you can see, there must be specific values over time. Like for instance, in the stock exchange, in Kenya, Nairobi Stocks Exchange, I was seeing that the values of Safaricom shares, for instance, have been on a downward trend recently. So, but you see now you are trying to compare it over a period of time. The price was about 40 Kenyan shillings per share, and currently I think it is trading at 20 and so on. So you are trying to look it over a period of time. That's what we call time series. And this one is mostly used in economics and finance because the main subject matter is stock prices and sales volume. And these are mostly variables. When we are talking about sales volume, stock prices, these variables are typically you explore them. You are trying to look at how have my sales been over a certain period of time. So always time will be on a horizontal line. Horizontal line is this one, what you call the x-axis. If you can see my cursor here, then of course the vertical line, the vertical axis is what the vertical line is what called the y-axis. So basically this one just can show you how maybe your stocks, how your sales have been performing over a certain period of time. And even as you look at this, we have three graphs. For instance here, maybe you are trying to compare Safaricom, Airtel, and Telcom shares over a period of time maybe. So you see, for instance, and I'm just using this as an example in case you are having an employee of Airtel and so on. Don't take it serious. This is just an example. So maybe if I can say the red line is maybe Airtel, then the green line is Safaricom, then the other one is Telcom. So you can able to compare. You see that, for instance, the Airtel sales have been on a low, like when you compare Airtel, Safaricom, and Telcom. I'm just using these graphs that you can see here as an example. You see that at no point has Airtel shares gone above those of Telcom. Then also another thing that we can see, if this is Telcom, we can see that there's a tendency that when Telcom sales go up, the Airtel sales also go up. There's a tendency because you see here when it rises, both rise. When it drops, both drops. Then when you look at Safaricom, Safaricom has been depicting a very different kind of line. But also we noticed that Safaricom shares recorded them. It has record as compared to the rest of these telcos. It recorded maybe the less price at a certain point. Let us say maybe you have your months here, so you are able to interpret it for business decision making. So we have the traditional forecasting methods, real life applications, but I just want to give you an opportunity maybe to ask 1, 2 questions. Then I give you our 15 minutes break. Then after that, we come back. Anything that is not clear so far, I know the terms are a bit technical. It's the first time maybe most of you are meeting. Okay, in case we don't have a question, we can have a 15 minutes break. Then we come back at 9:05 East African time. Yeah, come back at 9:05 East African time. Hello, I hope that we are all back. So maybe just to give a recap of what we have done. Basically, we have looked at data science predicting the future, and we have said that based on this also uh, um, we have traditional and modern or smarter ways, what you call machine learning. So, in terms of traditional methods, we have seen linear regression, and mostly we have seen that it looks at the assumption is that maybe an increase in one item will lead to an automatic increase on the other one, and a decrease will also lead to that, and so on. We have looked at logistic regression, and mostly we have said it is used in classification. For instance, in detecting fraudulent activities, detecting if an email is a spam email or not, among many others. I've looked at cluster, that's trying to group items together with similar features, with similar observations rather. Then factor, we have said that in case you have a lot of items, it just tries to assist you to reduce them. So, a last traditional method, we have looked at time series. Time series, you are saying that you are trying to look into your entire data set, and mostly here, the time factor is always there. Like you are trying to look at how some things or items have been unfolding over a specific period of time. Then we have now what we call the traditional forecasting methods. We want to look at the real life applications. So the first one, of course, we have many, but let me just pick a few. We have what we call the user experience, and for instance, when companies launch a new product, they normally design what we call surveys. And the purpose of these surveys, of course, as you know, is for data collection. And this survey can be used to measure the attitudes of the customers, maybe towards that product. So, analyzing the results after the business intelligence team maybe has generated the dashboards, including maybe grouping the observation by segments. And when we are talking about segments here, I'm talking about regions, and then analyzing each segment maybe separately to extract meaningful predictive coefficient. Coefficient is just a factor. A factor like if something is going to increase by 1.2 or 10% and so on. So what normal happens is that the results of these operations often lead to the conclusion that the product maybe needs slight but significantly different maybe adjustment in each segment in order maybe for that organization to maximize what you call customer satisfaction and so on. That is how maybe it can be used to enhance user experience, like how the customers interact with a certain product and so on. Another one, the another use case of this traditional method is forecasting sales. And this one mostly, as we have seen, that mostly time series comes in when it comes to forecasting sales volume, where time series mostly comes in. So what happens here is that first of all, the sales data in the organization has to be gathered maybe until a certain date. So what maybe the data scientists want to know is what is likely to happen in the next sales period, or what is likely to happen ahead, and how does it work, and so on. So what will happen now? You have to apply these mathematical and statistical models and run multiple simulations. Like simulation is like a trial, and these simulations provide the analyst with future scenarios. So what normal happens with these simulations? Maybe you run the first scenario, it gives you an accuracy of 80%. The second one gives you 85, the third one gives you 90, and so on. So you pick the one that will give you the highest level of accuracy. So it is now based on that scenarios that the company can make better decisions and of course implement adequate strategies and so on. So you will do this practically. When I'm talking about statistical, the beauty about this business intelligence data science, you are not going to do like the statistics that we used to do maybe back in campus or the mathematics, whereby most, maybe even in various colleges and so on, whereby maybe most people are asking that where am I going to apply this mathematics and so on. So here you might just go to an Excel, you have your data, you select regression and so on, then you have the output. You won't see anywhere where any kind of manual mathematics will be done. But the most important thing, what you learn is now how are you going to interpret it. Like as I said, if I run a simulation, the first one, and I get an accuracy of 10%, the second one 20%, the third one maybe it keeps on improving, I'll settle for the one that is more accurate, and therefore use it in making decision based on my data. Then another question is that who uses this traditional forecasting? So mostly, as we say that a data science, I think we define that as a very huge field that entails business intelligence, entails we saw machine learning engineers, it entails data engineers and so on. So as I say that data science also involves a person who employs machine learning techniques for analytics. So a lot of the work spills from one method to the other and so on. So as you see that also we have here a data analyst. A data analyst on the other hand is the person who prepares advanced type of analysis that explain now the patterns in the data that have already emerged, and of course overlooks the basic part of the predictive analytics. So, and again, I saw a certain advert in Safaricom. If I get it, I'm going to reshare. Safaricom were hiring a data analyst, but when I look at the JD, they wanted like a data analyst developer because they wanted someone who even understands big data. I am going to show you that I saw somewhere. I'm going to look for it. Yes, Collins. Collins, your hand is up. Okay, Collins, is it a question or you have just raised it by mistake? Okay, maybe allow me just to proceed in case you have your question. Will just prompt me to so that I can respond. So sorry, I was explaining who uses traditional forecasting, And I say that mostly also it is applied in this data science, and more so when you look at those terms, techniques, we apply them in machine learning. And therefore, of course, people might be interested to know what machine learning is, and that one now leads us to maybe to define what machine learning and so on. So maybe to define this machine learning, I can say it is a state of the art approach to data science, like how you are going to apply these data science techniques. So, and the critical thing here is that the main advantage that this machine learning has over any of the traditional data science techniques is the fact that it is core resides on algorithms. Let me explain what algorithms means. Basically, it means the directions that a computer uses to find a model that fits the data as well as possible. As I said, like I gave you that example of metadata. The issue of metadata, I think I use some to refer, like when you are completing a questionnaire, I might not be interested in the data that you are inputting. What I'm interested in is how are you navigating your screen and so on. So maybe if you give me access to your phone, you see these apps, for instance, when you download, you are requested if you can give access to the phone. So what normal happens, that access to the phone, maybe I'm interested to know the suspicious applications that you have in your mobile phone. Like if you have those applications that can allow you to access, maybe let me say a lending app without us knowing your location, it means you are not a good customer, because we can class the model can classify you as maybe a fraudulent customer, because you maybe why do you want us not to know your location and sorry, your location and so on. So you train the model. After the model learns and you have deployed it, it will continue improving and learning itself, so as to give you more accurate results. So the only difference between traditional uh, data science methods and machine learning is that we do not give the computer instructions on how to find the sort dependence. It takes the algorithm, and I have explained what algorithm is, and it uses the directions to learn on its own how to find that model and so on. So unlike the traditional data science, in machine learning, human involvement is minimized, and and maybe when you look at machine learning algorithms, specifically when we are talking about deep learning, they are so complicated, and human beings cannot genuinely understand what is happening inside the model. Therefore, like as I said, the most important thing is the interpretation. Like, are you able to understand your variables? Are you able to know how to import your data? Are you able to analyze and select the most appropriate features and so on? So it might not be easy to understand. So maybe we can explain what a machine learning algorithm is. Sorry, then I end there, because I don't the way I do train, I don't like giving so much content within a short period of time, because guys might not get it well. So machine learning algorithm is like a trial and error process, but The special thing about it is that each consecutive trial at least results to a good results as compared to the previous one. So, but what you need to be aware is that in order to learn well, the machine has to go through hundred of thousands of trial and errors. And with the frequency of errors decreasing, maybe the question is, how do you know the frequency of errors? We have some things that you learn called that are used to measure the accuracy of your model. As when you read there, you'll see like if you get this number, maybe if I train a model and I score below 80, that's not a good model that I can use in terms of this business decision making. It should be 80 and above and so on. So once the training is complete, the machine will be able to apply the complex computational model it has learned to the data and give you some kind of very reliable kind of predictions. Yes, it cannot be very accurate. These models and so on cannot be 100% accurate, but it can assist you to achieve, like even if we are saying that it assists in reducing fraud, we are not saying that it will reduce fraud by 100%. Sometimes they reduce fraud by 75%. Of course, if it reduces by 78% for a company or organization, that's I can say a good achievement and so on. So, in line with that now, we are going to look at three major types of machine learning from tomorrow. We have what we call supervised machine learning. We have what we call unsupervised machine learning. And we have what we call reinforcement learning. So, I don't want to proceed from there. I'll share the recording of today's session before 10, but I want to give you room for questions. You can ask questions. Any questions? Any questions? Let me also try to pick. People who have never spoken in this class. Fiona, I don't know if you have ever spoken, but what have you learned today, Fiona? Fiona, anything that you have learned today?
Okay, good evening. So I think what I can say I've learned today is basically about the predictive analytics, which is the data science of predicting the future. And we've looked at the traditional data science method, like the linear regression, the logistic regression, the cluster, factor analysis, and time series. And then maybe the people who use the traditional forecasting, like the data scientists and the data analysts. But maybe what I can just say, maybe as an observation, is maybe from the next class when we are giving examples. I know we've given a few real life examples, like the industry real life examples, but maybe we can just try and give more of that to make it easier to understand. I don't know whether that will be possible.
Okay, thank you so much. Which industry, Fiona, are you working in?
I'm in the banking industry.
Okay, banking and finance. Okay.
Yes.
Okay, thank you for that. Shanice. Yeah, I think this name is pronounced as Shanice. Anything that you have learned today? Okay, Gertrude Angom. Anything that you have learned? Gertrude Angom. Okay, no, nothing. Maybe on your side, do you have anything? Sorry, anything to add or a comment, a suggestion? Yes, Ephraim.
Good evening again. I think I'll support on this issue of examples. We need maybe more real life scenarios or explanations to really understand some of the terms and the traditional methods, how we reach to some areas where they were used and how they are going to be used, and in the predictive or the analysis coming to the new methods like the machine learning, how are they interlinked? I think that's my whole point. Thank you.